You've probably heard the term black box when it comes to AI. You know, a model so complex that we can see the data going in and the answer coming out, but the why behind it all is a complete mystery. Now, that's a massive problem, especially when these systems are making life-changing decisions. Today, we're going to crack open the toolkit and look at one of the most practical ways to shine a light inside that box.
Now, many of you will already know about Shape. It's considered the gold standard for AI explainability. It's rigorous, it's built on solid mathematical ground, but it's also heavy. It can be really, really slow. And this quote here, it just perfectly sets the stage for our conversation. Sometimes you don't need absolute perfection. You just need a fast, practical answer. And that's exactly the space that Lime was built to fill.
The name Lime really tells you the whole story. Let's break it down. It's local. And that's because it focuses on explaining just one single prediction at a time, not the entire sprawling model. It's interpretable because its final output is something so simple that we humans can actually look at it and understand it. And what's absolutely crucial is that it's model-agnostic. This means Lime doesn't care what your black box is. It could be a massive neural network, a random forest, anything. It can still help you understand it.
All right, to really get what makes Lime tick, let's just forget about all the code and the algorithms for a moment. Instead, I want you to think about maps. Seriously, this one single analogy is the key to understanding everything about how Lime works and why it's so useful. Think about a flat map of the world. You've seen them 1,000 times. Globally, we know the Earth is a sphere. It's complex. So when you try to squash it onto a flat piece of paper, you get all those weird distortions, right? Greenland suddenly looks bigger than Africa, and Antarctica gets stretched out into this huge smear along the bottom. A single, simple explanation, our flat map, just can't capture that global truth perfectly. Well, a complex AI model is exactly like the globe. But what if you aren't trying to map the whole planet? What if you just need a map of your own back garden? In that small space, the ground is, for all intents and purposes, flat. A simple, flat map isn't just useful, it's perfectly accurate for that small area. And that, right there, is the entire philosophy of Lime. It says, forget trying to understand the whole complicated model. Let's just build a simple, accurate, flat map for the tiny neighborhood right around this one prediction.
Okay, so that's the big idea. But how does Lime actually draw this local map? Let's make this really concrete with a story, something that happens thousands of times a day.
So, let's meet Anna. She applied for a loan, and a completely opaque black box AI model just rejected her. No reason given. Anna deserves to know why, right? We're going to use Lime as our detective to find the answer.
Lime has this really clever 5-step game plan. First, it takes Anna's application and creates thousands of slight variations of it. Think of them as neighbors. A little more income here, a slightly different age there. Second, it takes all of these fake applications and feeds them to the original black box, just to see what it would say for each one. Third, and this part is key, it gives more importance or weight to the variations that are most similar to Anna's real application. They're the most relevant after all. Fourth, using only this local weighted data, it trains a brand new, super simple model, like a basic linear regression. And finally, the fifth and final step, it just reads the results from that simple model. That's where the explanation lies.
And here it is, the payoff. That simple little model that Lime built showed a big negative number, a negative coefficient attached to one feature, debt ratio. And that's it. That's our answer. For Anna, in her specific situation, her high debt ratio was the single biggest reason the model said no. It's not a fuzzy guess, it's a clear, actionable explanation.
Now, this map-making ability is great for numbers on a spreadsheet, but this is where Lime gets really, really cool. Its true power becomes crystal clear when we apply it to the messy, unstructured world of text and images. So imagine an AI is trying to figure out if this film review is positive or negative. It's a tricky one, right? It's mixed. How does the model weigh the good against the bad? Well, Lime can show us exactly which words are doing the heavy lifting.
The way it does this is just ingenious. Lime starts playing a game of what if. It temporarily removes words from the sentence. For example, it takes out the word breathtaking and asks the model for its opinion again. If the model's positivity score suddenly drops, well, Lime knows breathtaking was a huge positive influence. Then it does the opposite. It removes predictable. If the model's opinion suddenly gets more positive, then it knows predictable was the key negative driver. And what you get at the end is this beautifully simple color-coded text that shows you exactly what the model was thinking. Now with images, the approach has to be a little bit different. You can't just turn individual pixels on and off. That would be complete chaos and wouldn't really tell you anything useful. So Lime does something much smarter.
It first groups similar pixels together into coherent regions, or blobs, called superpixels. Think of it as breaking an image down into its meaningful parts.
And then, Lime plays the same game it did with the text. It starts turning these regions off, basically just graying them out. And it keeps asking the model, what do you see now? Can you still see the cat? By watching which grayed out areas cause the biggest drop in the model's confidence, it can build a heat map. This shows us exactly which parts of the image the AI was focusing on to make its decision. It's a visual explanation of the model's attention.
So Lime is fast, it's intuitive, it's incredibly flexible. It sounds almost perfect. But it's not a silver bullet. And we really have to talk about its one major weakness, something that anyone using it needs to be very aware of.
Remember how Lime works by creating thousands of random neighbors? Well, that's the secret to its speed. But that very same randomness is also its Achilles heel. Because the samples are random, the explanations it produces can sometimes be unstable.
Let's go back to Anna's loan application. If we run Lime once, it might tell us the most important factors were her debt ratio, followed by her income, and then her age. Okay, fair enough. But what if we run it a second time, on the exact same application? Because the random neighbors it generates will be slightly different, the explanation might change. As you can see here, it might still say debt ratio is number 1, but now it thinks age is more important than loan amount. In a low-stakes scenario, that's probably fine, but for a really high-stakes decision, that inconsistency is a problem. You can't fully trust an explanation that changes every time you ask.
So this all brings us to the most important point. How do you choose the right tool for the job? This isn't about Lime being better or Shop being better. It's about which one is the right one for your specific need, right now.
And this table just lays out the trade-offs perfectly. Lime is all about a fast, local approximation. Shap is built on solid game theory, giving you stable, guaranteed results. Lime is fast, Shap is slow. Lime can be a bit unstable. Shap is consistent every single time, and that really tells you when to use each one. Use Lime for quick, intuitive checks when you're just exploring or debugging a model. But you bring out Shap for the rigorous, high-stakes audits, where every detail has to be perfect and repeatable.
So if there's one thing to take away, it's this. Think of Lime as your quick, hand-drawn sketch map for getting your immediate bearings. And think of Shape as the official certified surveyor's blueprint for a major audit. They aren't competitors, they're complementary tools in the same toolbox.
And that brings us right back to our mapping analogy and a final question for you to think about. Is it better to have a fast, maybe slightly imperfect map of just your immediate area right now? Or is it better to wait for the slow but perfectly accurate map of the entire globe? The answer, of course, is that it depends entirely on what you're trying to do. And a skilled cartographer knows how to use both.